Greetings and welcome to the introduction to astronomy. In this week's Astronomy of Other Cultures, we continue looking at Muslim astronomy, and we'll talk about the astronomer al-Battani and look at his contributions to astronomy. So let's go ahead and get started. We know that al-Battani lived from about 858 to 929 and worked in Syria, and like many of the people we've looked at, has worked on both astronomy and mathematics. And essentially what al-Battani did was to lay a foundation for modern astronomy. What does that mean? Well, in astronomy, he did things like believing in the geocentric model. Now we know that the geocentric model is incorrect, but this is what was believed at the time, going back to the ancient Greeks, and made sense because the Earth did not appear to be moving. We now know that it is, and we have other measurements that we can make to demonstrate that. But it was considered a fact at the time that the Earth was not in motion. One of the other things he did was to discover the reasons for an annular eclipse. Now we see an example of an annular eclipse here. What is an annular eclipse? Well, this is an eclipse that occurs when the distance between the Earth and the moon is greater than normal. So the moon is a little bit farther away, making it appear a little bit smaller. And therefore, when it lines up with the sun, even if it lines up perfectly, it can't completely block out the sunlight. So we see something like this, sometimes called a ring of fire, as you have a ring of sunlight visible around the limb of the moon. He worked on refinements for the Almagest. We've seen that with other astronomers as well. And again, the Almagest was the key work for a long period of time. But it didn't just sit there stagnant. It was constantly being worked on and adjusted by various of astronomers of different nationalities. Using larger instruments and getting more accurate observations then allowed for refinements of the model. And we know that he improved the measurement of the Earth's tilt, which tells how extreme our seasons are. The more tilted it is, the stronger the seasons, the less tilted, the less strong the seasons would be. And he got a better estimate of that. And in fact, a lot of al-Battani's work is referenced by Copernicus within his works as well. So a lot of this work made its way to Europe during the Renaissance, and then was used. The things that were changed and adjusted by the Muslim astronomers that we've been looking at were then used by the astronomers of the Renaissance to continue developing astronomy. Now, in terms of calculations and mathematics, one of the things that he used was what is called spherical trigonometry and spherical trigonometric functions to do the astronomical calculations, which make things more accurate. If you studied geometry and such, you've probably learned plane geometry. And that is how things are normally done, where the angles of the triangle will add up to 180 degrees. Well, when you do astronomy on a sphere, that's not necessarily the case. And in fact, in a sphere, on a spherical triangle, you can actually have each of the angles being 90 degrees in certain triangles. So you can have a spherical triangle where angles do not necessarily add up to 180 degrees. But this is again more accurate and gave us better accuracy and calculations, and one of the things that was introduced by al-Battani. So let's go ahead and finish up with our summary and what we've looked at today. And what we've looked at is al-Battani lived from about 858 to 929 and laid a foundation for modern astronomy. Looked at how he improved some instrumentation, understanding of eclipses, and the measurement of the tilt of Earth's axis, as well as improving methods of calculation. So that concludes this discussion on al-Battani and his contributions to astronomy. We'll be back again next week for another astronomer of the Muslim world. So until then, have a great day, everyone, and I will see you in class.